Hello again out there in remote learning land. Today's hot topic. We're talking about the daily and seasonal temperature lag, right? When you guys, when your Wi-Fi is lagging, right? Your computer's running slow, takes time to catch up. Well, that's a similar thing here with the Earth. When the sun beats down on the Earth doesn't just heat up in a second. Earth is a big place, right? A lot of water, high specific heat values, so it takes time to heat up. And that delay in heating is called a lag. Okay? It happens every day. It also happens throughout the year. And we'll show you the two different examples of that. All right? Start out with a little thought here. If summer starts on June 20th, June 21st, right, the official first day of summer, you ever notice it doesn't really get really hot until the end of July, beginning of August? The sun was at its highest point in June. Why does it take another month or two for the Earth to really get hot? Well, it's that same thing we were just talking about, right? It takes time for the Earth to heat up. And when it does, then you will reach your highest temperatures. Okay, so this little clip here is the polar bear plunge, they call it. It's a group of people that jump in the ocean, usually like on a New Year's Day type of thing. This was New Year's Day a couple years back. They did it to raise money for whatever charity, but you think, my gosh, that's got to be cold, and it is cold. But remember, Earth won't get to its coldest point until after that, right? The shortest day of the year, right? The first day of winter, December 21st. And then it really gets cold in like January, February. So the water isn't as cold as it could be, but it's still cold. Check these crazy folks out.
Swimmers taking the polar plunge welcome the mild temperatures this New Year's Day. Go for it, but Long Island Sound was still pretty cold. Nearly 70 people made a splash to benefit New Haven Parks. The Elm City Parks Conservancy sponsors the event at Lighthouse Park. And those who did brave these waters are raising money for their favorite park or open space. The swimmers pledged about $10,000 this year.
It was fun. It's exhilarating. It's very cold. It's icy cold. You could feel it when your legs begin to lose consciousness, and that's when I knew I had to swim to shore before I drowned.
Good thing today's plunge marks the 6th year of the event.
So this is a guy in freshwater who tries a polar bear plunge. Oh! Careful with that freshwater, folks. Unlike saltwater, freshwater freezes a lot sooner and faster. Plus a lake, the water isn't moving as much, so it will freeze a lot faster, right? The ocean, the salt, lowers the freezing point, plus you have constant motion with the currents and the waves. Has to get a lot colder before it freezes. So that guy's lucky he didn't get seriously hurt. Whew. Polar bear plunge. All right. So how do we define a temperature lag? Well, it's when the maximum or minimum air temperature is delayed because it takes time to heat up and cool down the Earth. And that's what this chart shows you here. You can see maximum maximum temperature is reached. The peak is reached after the maximum sunlight, right? Maximum insolation. And that right there, that delay, looks like about a month and a half or so. That's called a temperature lag. And that, of course, is a seasonal one because that's talking about throughout the year. Okay? Earth takes time to heat up and cool off. This is another chart with that same concept. We'll be interpreting this chart in just a little bit. Okay? So get your following terms in there. Insolation, break it down phonetically, right? Insolation. Incoming solar radiation. And that's what's going on there. That is energy from the sun. And of course, most of what reaches the Earth from the sun, it's in the form of light, right? The heat doesn't travel very far in space. There's no air to conduct that heat. But light can travel in a vacuum. And that's how the Earth gets heated. We absorb the sun's light, and then we turn that light into heat. All right. Terrestrial radiation is what we just mentioned. So the light gets turned into heat, and then the heat gets released into the Earth's atmosphere and warms up the Earth. Okay? Make sure you have those two terms down in your notes there. All right. A balance, of course, when the energy going out equals the energy coming in, and we're roughly in a radiative balance, right? Earth's average global temperature is 59 degrees Fahrenheit. So, yeah, in a sense, we're in a balance. Of course, at night we get cooler, in the day we get warmer. In the summer we get warmer, in the winter we get cooler. But overall, right, we're in what a radiative balance, and that's what this is talking about here. Okay? In the atmosphere, that heat gets trapped by what we call greenhouse gases, and we'll talk about those a little later on. Everybody thinks they're a bad thing. No, they're essential for life on Earth. Of course, too much is a problem, right? But without greenhouse gases, we'd be like Mars. We'd be frozen. Okay? Check out this chart here. This is day versus year. So the day, the highest intensity, we call that solar noon, and it's roughly 12 p.m. But the highest temperature, of course, won't come till after that. The lowest would be when the sun is setting on the horizon. Okay? And there it is. Your highest temperatures come several hours after the sun's at its highest point. That's that daily lag. And the lowest temperature, if you think about it, it doesn't start to get real cold till the middle of the night, right? And then all of a sudden, right before sunrise, it's at its coldest point, roughly 5 a.m., and then when the sun rises, of course, temperatures will start to go back up. This phenomenon occurs throughout the year, so the highest intensity would be June 21st, roughly, plus or minus a day. We call that the summer solstice, and everybody's looking forward to that, right? We just passed the winter solstice, and of course, that's the lowest intensity, the one we just passed, right? December 21st, plus or minus a day. However, even though the highest intensity is June 21st, we don't get the hottest until the end of July, early August. And also over here, we don't get the coldest until after December 21st, right? Sometime in January or February. Okay? Again, this is the temperature lag on Earth. Okay? A couple other quick notes. Make sure you get them in. Why do we have a daily lag in temperature? There's some bullet points. Make sure you get those in your notes. And this is the seasonal lag. Make sure you get those in your notes. Okay? All right. So we're going to put you guys in the little chat groups to work on a yearly temperature lag here. Make sure you get all those questions answered. This is kind of a scrunched up diagram of the one you have in your notes there. So it's the yearly heat budget. Make sure you go through that. And, of course, when we meet back in the meet, we'll see how you did. All right. See you in a bit.